All right, we're solving equations today. That tends to be kind of our bread and butter as mathematicians here. So first, just to review a quick absolute value, the idea of these equations. If you think about kind of what could be behind the pen right there, absolute value of something is 7. There's two possibilities. Absolute value of 7 is 7, but also absolute value of -7 is 7. So what's behind the pen right there is either 7 or -7. So x plus 5 is either 7 or x plus 5 is -7. And so that's why we get two different answers for our absolute value equations. So if we have something more complicated like this here, first you have to make sure you isolate the absolute value at the beginning. So add that 1 over first. Absolute value x squared minus 3x is -4x plus 6. Then once the absolute value is isolated by itself, then you can write the two different equations. So the first one, just drop the absolute value. And then the second one, you keep what's inside the absolute value the same. And then this right here could either be the same or the opposite. So we need the opposite of -4x plus 6, which is 4x minus 6. What we're doing is the opposite of -4x plus 6. And so then we just have to solve those two equations there. So we want to get everything on the same side, make it equal to 0. So we'll have x squared plus x minus 6 is 0. If I'm ever going too fast for you, you're always welcome to pause the video for a second. And then we've got x plus 3, x minus 2 is 0. And then that 0 product property. If x plus 3 being 0 gives us -3, and x minus 2 being 0 gives us x equals 2. So we get two answers over there from that branch, and then we'll get more answers over here from this branch. Again, get everything on the same side, collect all these like terms. And then factor the quadratic. And so we end up getting 4 total solutions for this problem. All right, so that's absolute value equations. Then let's go ahead and take a look at this radical equation here. Now there's going to be kind of a slick trick to solve this a lot easier that we're going to look at later on. So if you're thinking of a trick, hold on to that. We'll come back to that. I do just want to make sure that we all remember how to solve radical equations. Roots are called radicals, how to solve those in general. But for this particular one, there is a trick. We'll talk about that later. But in general, radical equations with square roots, you want to isolate the root, isolate the radical. So I'm going to add that over to the other side. Let's keep everything else here and just add the 2 root x over there. Now you could square both sides right there if you wanted to. Technically, we're supposed to isolate the radical. So, you could divide by the 2 and then square both sides if you'd like to, but this is isolated enough. We could go ahead and square both sides now. And just make sure you actually multiply that out there. That's x minus 15 times x minus 15. There's no just showering of power, some people say, or something like that. You can't just square those two different things. Multiply that all out. X minus 15 times x minus 15. You're going to get x squared minus 30x plus 225. And then 2 squared is 4. Square root of x squared is x. And then collect your like terms, subtract that 4x over there. X squared minus 34x plus 225 is 0. That one might seem a little bit difficult to factor there. I mean, if it doesn't factor, of course, there's always the quadratic formula. We should know that, but this one actually does factor. I'll give you a hint. If it ends in 25, that means that 25 goes into it. So you could think about how many quarters it would make, or it would take to make $2.25. That would be 9/4. So 9 times 25, 9 and 25 gives you the 34. That's a little bit of a trickier factoring. Probably wouldn't give you something quite that tough on a test or anything like that. And so we get x equals 9 and x equals 25. All right, a little bit of work there, some tough factoring, did a bunch of algebra, probably feeling pretty good. Fortunately, we are not correct right now. That is not the correct answer. Now, we didn't make any mistakes. There's no mistakes in each step that I made right there, but still, that's not the right answer. Let's try checking these answers here. Let's try plugging these back in. Substitute those values into the original equation. So if I try x equals 9, I'm going to have 9 minus, let's see, square root of 9 is 3, 2 times 3 is 6, 9 minus 6 minus 15. Now that's supposed to equal 0, but 9 minus 21, last time I checked, does not equal 0. So this is actually not a solution right here. So this happens sometimes in math. Sometimes we do all the right work, but we get extra solutions. Now there's a funny name for it though. Mathematicians like to sound smart. They don't just want to call it extra. The word they use for it, they call it extraneous. This is an extraneous solution, which means it's not actually a solution. It doesn't actually work. Now if we check the other one, let's plug 25 in there. 25 minus 10 minus 15, that is going to equal 0. That one does work. So our answer to the problem is just x equals 25. That's it. And we've got that extraneous solution, that extra solution that doesn't actually work. What's happening is, let's say you started with the equation x equals 1. It only has one solution, obviously. But now let's say that you squared both sides, and then you ended up with x squared equals 1. Well, how many solutions does x squared equal 1 have? Now you've got 2 solutions. Now you've got x could equal plus or minus 1. So if x equals 1, it is true that x squared also equals 1. So this is a valid step. This is something that we're allowed to do, that we use in math, but it adds solutions. It adds extra solutions into the problem there. So we just have to check our answers. Check our answers, make sure that they actually work. Okay. So now if we take a look at this one, we don't want to try to factor it right now. I mean, you could factor out the x squared, but that's not going to be helpful. When we factor, we want it to equal 0. We need that 0 product property. So we want everything on the same side. And then you notice there's this x to the 4th and x squared here. Some of you guys might remember from Algebra 2 Honors, there's a nice little trick here they call U substitution. So what you can do is you can make u equal x squared, and then this thing that might have looked a little bit uglier with an x to the 4th in there, well, if u is x squared, x to the 4th, well, that's x squared squared, squared squared, and so this right here would be u squared. 10u squared minus 79u plus 37 is 0. And so now that's a quadratic. So we took something that seemed a little bit more complicated, made it a little bit more simpler as a quadratic. Now that one there is not too bad. It's not, I don't think, as bad as the one with the 225 right there, but some of you might struggle a little bit on some of these. Sometimes we're going to give you some numbers that seem ugly, but they're not quite as bad as they might look. So go ahead and give this a try. Try factoring that, try solving that. Remember, we did the U substitution. Get down to that final answer. You go ahead and give that one a try. And then once you've done that, see if you can go back and see if you can see the clever way to solve number 3 a little bit easier. You go ahead and give that a try here. So You can double check your answer there. The key was make sure you notice 37 is prime, so lock in the 37 and the 1 first, and then you can play with the other pairs for the first part of the factoring there. If that was a little bit rough for you for factoring that, definitely practice that. We're going to give you a lot of this uglier factoring. It's going to show up a lot in this class. So if that was hard for you to factor, make sure you get a lot of practice. And then make sure that you went back and actually solved for x and didn't just solve for u. You got to actually solve for x. And then you can see the trick here. You could actually make u equals square root of x, and then that will allow you to turn number 3 into a quadratic as well. So I like to call these quadratics in disguise. Anytime you have a variable term where this part is the square of that variable part right there, you can use a u substitution. It's a quadratic in disguise, and look how much nicer that is then. The factoring's so much easier. The extraneous solution kind of pops right out at you. We know that square roots can't be negative. Square roots are always positive. So nice, clever way for that one. All right, so then let's take a look over here at what we call a rational equation. Rational in math means fractions. So of course for these we have to fraction bust. Make sure you only fraction bust if it's an equation, if you have that equal sign there. We're using the multiplication property of equality. If it's an equation, you're allowed to multiply both sides by the same thing, and the equality will stay true. And so over here, x minus 2's cancel. Multiplying by 1 doesn't do anything, so we get x plus 2. Over here, the x plus 2's will cancel, and so then we need to multiply the 3 by the x minus 2. And then over here, the whole denominator cancels, so we're just left with 6x, and there's no multiplication to do at all there. So let's distribute. And then I'll collect my like terms over here. And then I'll just get my x's on the right side, subtract that for x. Again, if I'm ever going too fast for you, just pause the video. Negative 4 is 2x, divide that over, and we get negative 2 equals x. All right, again, a little bit of work, but we got there. And if you're feeling happy with yourself, I'm sorry to tell you that that's not the right answer. That is incorrect. Take a look back at the original problem. We had x plus 2 in the denominator. If x is negative 2, then we'd have 0 in the denominator right there. You're not allowed to have 0 in the denominator. 0 in the denominator is undefined. So actually, x is not allowed to equal negative 2. Remember that funny word for this? This one is an extraneous solution. Well, what does that mean for the problem? Does that mean the answer to the problem is extraneous solution? Does that mean the answer is x equals negative 2 but extraneous? No, none of those things are correct. The correct answer for this problem would just be no solution. The only possible answer doesn't actually work. So we're done. There's nothing that works. No possible x's will make that equation true right there. Okay. So again, make sure you watch out for these extraneous solutions here. You got to try plugging those answers back in. Try to substitute that value for x back into the beginning and see if it actually works. Now you should always do that, but there are actually just only a few times when these extraneous solutions, they're really just extra solutions, but we like to sound smart, when those are possible. And it has to do with these cases where there's restrictions in math. So one of the restrictions in math is that you can't divide by 0. You're not allowed to have 0 in the denominator. So in all of these rational equations, it's going to be possible that you're going to have an extraneous solution when you have fractions, because there's a restriction with fractions. We saw another type of equation earlier where we had an extraneous solution where there was a restriction, something that you can't do in math. You can't square root negatives, at least with real numbers. We call those radical equations, where you have roots. Can't take the square root of a negative. You can't have square roots equaling a negative when it comes to real numbers. And so that's another time it can happen. There's actually one more restriction in math, and it's absolute value. Absolute value is always positive, and so there's times when absolute value equations can give you an extraneous solution. All right, so now for something a little bit different here, when I say solve for y, I'm not trying to find like y equals -2 or y equals 7 or y equals a number. I'm trying to just isolate y, trying to just get y by itself. Now, at first, that might seem kind of tricky because y shows up in two different places. If we're trying to get down to just y equals, trying to isolate y, how am I going to turn those two y's into a single y? That might seem a little bit difficult. That almost might seem like magic. How do we turn two y's into one y? Well, there's a trick. You guys ready for the magic trick here? I'm going to turn two y's into one y. Here you go. Ta-da! It's magic. Factor it out is the trick. If you factor out the y, it will turn those two y's into one y. And then you can just divide over that x plus 2. And now we've isolated y. We've gotten y by itself. That will come up a few times throughout this course, this kind of trick of factoring out a variable to isolate it, to solve for it. So tuck that away, that little magic trick there. Turn two y's into one. And so then we looked at using the calculator in the previous lesson, just a little bit of making sure that we can solve using the calculator here. If we're actually solving an equation. So all this stuff we did before was if we want to solve by hand, what if we want to use the calculator? So something like this, there's two options. So we'll say option A is that you can graph the left and graph the right separately. So you can say y equals x cubed plus 3x squared. And then you can say y equals x plus 3. Graph those two separately. And then we did look at yesterday how to find the solution when we're graphing those two separate things. See, if you remember, it was in the calc menu. You want to do calc intersect. Calc intersect. And so I would just graph those two. So x cubed plus 3x squared, and then x plus 3. And remember, always do zoom 6, zoom standard. And then you can see the intersection points are the solutions. And so second trace, calc intersect. And then you can just hit enter, and it will give you one solution. Notice on this one, the original problem only had x's, so we would only need the x for our answer. So we can just say x equals -1. We don't need to worry about the y. And then when we want to find other intersections, let's go back to calc intersect. You just need to move the cursor closer to one of the other answers. Use the left or right arrows, move the cursor around, and then hit enter. Keep hitting enter until it gives you an answer. Again, we only started with x, so we only have to give x in the answer. I'll be lazy / efficient, just say plus or minus 1 there. And then the last intersection, move that cursor over to the left, keep hitting enter, and there we go, -3. So there's our answers. So one option, graph the left, graph the right, do calc intersect. Another option is I could get everything over to the same side there. Let me subtract the x and subtract the 3. So x cubed plus 3x squared minus x minus 3 equals 0. And so then I could graph y equals that, and then I could do calc 0. That's another option. Right. And so if we looked at that one, I think we're probably okay with calc 0, and I'll do calc 0 on the next example there. So you can give that a try if you're a little bit rough. Definitely let me know. Come to tutorial or stick around after class, and we can look at doing that. But you would just graph everything on the same side there. And then also, just a note, if we wanted to do this, by hand, take a look at this here. If you wanted to do this by hand, see if you remember there's a trick. It's called factoring by grouping. So you would do it, pull out the x squared on the left, and then factor out a -1 for this half here. And then the x plus 3 is now a GCF that you can factor out. So factor out the x plus 3, and you've got x squared minus, that's a 1 right there, x squared minus 1 left, and so you see you get our -3 and our plus or minus 1 as the solutions there. So if we look at this one, I think I would probably do the equal to 0 option. If you try calc intersect, sometimes you won't be able to see the different intersections clearly. Sometimes they'll kind of overlap and be too close together. So typically what I'll do is I'll do the calc 0 method, unless it's a system. If it starts out as y equals and y equals, and you actually want the y values, if it's like for problem 1 here, if it started out like this problem right here, then you would definitely want to use calc intersect, because calc intersect will show you the x's and the y's. So if it starts out like that, do calc intersect. If it starts out as just a single equation, then I would probably just do calc 0. It's up to you though, either way. But this one would be a little tough to find both answers with calc intersect on this one. All right, so x squared minus 4x plus 3.9. I'll do zoom 6. And so here's the thing, you're probably familiar, x squared quadratic equations, they usually have 2 solutions. Once in a while there's only 1 solution, or could be no solutions, but there's usually 2. So if you see something like this, don't just trust like, oh, it must just, barely touch the x-axis and only be 1. Don't trust the first window that you see. Investigate a little bit further. You could use a zoom in, move the cursor over to here, zoom in. I would do a zoom box. Let's do zoom box. Let's draw a little window right around here. Right around where it is either touching or crossing the x-axis, and let's see what happens. Hit enter. Take a look at that. It does cross the x-axis twice. So when we do calc 0, second trace, calc 0, go to the left of this solution, and then just the right of that one. Make sure it doesn't go past the other one. You want to really kind of narrow in a window and interval of where that solution is without including any other ones. And then hit enter one more time. And there's one answer. Again, we're going to do 3 decimal places because that's what AP Calculus does. So we're going to say x is about 1.68. Now you are allowed to either round or truncate. So you are allowed to either say that that's 3 or then round it up to 4. Either one is acceptable. I'll round, but you could just say 3. Either one's fine. And then if I want the other solution, calc 0, need to go over here, left bound there, right bound here, hit enter, and my other solution is about 2.316. Right. And finally, real quick, I get this question a lot. We've got trace when we know the x value. So like on this one right here, if I wanted to do trace and then x was 2.5, it will tell me the y. So if you know the x, want the y, trace is great for that. I get a lot of questions about what about the other way? What about if I know the y and I want the x? Unfortunately, there's no great way to do it. You just have to solve the equation. You just solve the equation, EQN, but I forgot to mention up here, EQN is my abbreviation for equation. I'm saying a lot. We mathematicians, we're notoriously lazy / efficient. Sometimes we always going for efficiency. Sometimes we stray a little bit into being lazy, but we're trying to be efficient as much as we can. So you just have to solve the equation x squared plus 5x equals 8 in your calculator. So either calc 0, calc intersect, something like that. So there's no, like in the table, making dependent be asked, that just doesn't work well. It doesn't do what you would want it to do. There's nothing like a trace. You just have to solve the equation, calc 0, calc intersect.